Excellent. Well, welcome everyone, and it is always a pleasure. I've loved so far some of the comments that y'all have had and working through this. One of the first things I want to do is do just a little bit of housekeeping on a couple of little things. So I'm going to share my screen real fast and take a look at our submission folder. Here we go. So everybody see this? Give me a thumbs up. Excellent. Good enough. All right. So far so good. What we have a couple of things, Jay, on your submission. One of the things that I'm going to change about it is I'm going to right click on here and I'm going to rename it for the, I don't remember which task this actually was, but it's going to be renamed for TTU S21. And let's see, I'll just do Jay-Z for right now. Initials, and which I'll put X right there for that. So when you all do your submissions, watch the actual naming convention of the file so we know whose it is, and we can get back to you there. The only other thing that I'm going to show is like, looks like Adam on yours, it went to the main page of the submission instead of the actual task folder, the lesson with it. So I'm just going to drag it into lesson 1. So it would just say you don't have access, and I'll figure out which one, Jay, this one is in a second. So, but yeah, just kind of watch that when you all are turning your stuff in. Actually go in the folder to put it on in. So that is handled. I want to show you also, one second, and we have now added in some new materials since you all have received your printers, which I was impressed they got through that fast. We have added a new folder, a couple new folders for specifically training on your particular hardware. So in the XX folder here, hardware training, you're going to find 3 folders of getting started with the Genius, getting started with the Mars, and an overview of the filaments and those sort of things. Now, the number 3 one is as you get into it, generally with the filaments that you got are just PLA. But with the Genius, there are several tutorials on not only putting it together, which some of you have already done, but also one of the most crucial things with the Genius is that bed leveling. And so we have a detailed video on here, and in fact, I'll probably provide another one a little bit later on that's even more detailed, because that first layer leveling is the most crucial part. And it's hard to represent that in a virtual fashion, but it's all about how it feels when you're using a piece of paper to level it. And so we're trying to get that feeling and that sense in there, but that's a critical component. And then we actually have some slicing training specifically with Cura. Now we'll provide more of that in the upcoming lessons too, but this is a get you started with the Genius. And it's a great little printer, super fast. The heat bed is amazingly good, and it's a direct drive, so you get a lot of push through there, so that's awesome. Then we have the video for dealing with the Mars and the training. So you can go through the Mars training with the resin printers. They're a little bit messier, so there's just more videos on how the proper handling should be. Always remember to wear gloves when you are handling the fluid. And there's also some details on the printer settings. So that is found now within your training material, same place your lessons are, and it's just in the XX folder, so it should always show up at the end. Also, I have just released out your lesson 3, and you will see that on the screen it's just a lot of tutorials. Now, I say this as a caveat, many of you already know CAD, you may already use Fusion, feel free to skip over whatever you see fit to skip over. Some of you are SolidWorks, maybe Pro-E, Inventor, and there's a lot of alignment in with how this works. Again, pick and choose as you see fit. I will say this, however, in the interest of the students, Fusion is gaining a lot of popularity outside of the normal manufacturing field. So folks that would never get into SolidWorks are getting into. Welcome back. So with that in mind, if you think you're going to be teaching folks that maybe just a little bit on the outside of the manufacturing field, maybe they're coming to you from the art side, maybe they're coming to you from the marketing side, because we do welcome everyone into additive manufacturing, then I encourage you to at least be more familiar with Fusion. just for their benefit over time. So we have plenty of tutorials here. You'll notice that we do a lot of project-based training where I'll come up with some kind of part we're going to make. We're going to step through that process. It's very logical. It's very linear. And we've honestly found that to be the best way to build in the skills of troubleshooting, things going wrong, things not working, and the tricks versus just like, here's a tool, do this, here's a tool, do this. It's all about the project-based learning. So it's all there, but I realize it's a lot of material. And it's there for you to utilize if you like it. If you know it stuff, roll on. We also put in there that part of like, here's how you get Fusion. Some of you already have it. You can obviously skip those. And generally what happens is, as we see mistakes, not only in this lesson, but just like in general, our approach is to turn around and address those mistakes in another tutorial so other people can work through that. So a lot of material there in lesson 3. I'm also about to finish up lesson 4, which introduces a couple things that we utilize heavily in the additive manufacturing realm. 1, a little bit more Fusion tutorial in there, but 2, cloud storage transitions. Basically STL files, G codes. It's all about being able to send this stuff remotely to each other and to other printer sites. And those files get big. So instead of us trying to transfer them by uploading them and doing things like through our learning management system or emails, we just do links. So we'll say, here's the email, here's the link to my personal cloud drive, here's my STL file, I can upload and go. So we make sure that there's tutorials built into this lesson on using Google for that effectively. The bigger component to this lesson, though, in lesson 4, is Mesh Mixer. If you have familiarity with Mesh Mixer, awesome. If not, you are going to have a great love-hate relationship with Mesh Mixer, because it is probably the most powerful tool, one of the most powerful tools for additive that's underutilized. And that is because it can take these STLs that you make in Fusion and SolidWorks and Inventor and make them better. It can take an STL file that someone has sent you, and you can improve it by adding in a new feature that you couldn't add in any other way. It's just extremely awesome in its power and its ability to improve your products. It does have some nuances that get annoying real fast, but it's free, doesn't even require a login. A lot of training material there too, a lot of tutorials. We're giving you as much potential material as you can. And I'll say this too, anything that you like as a potential use for students, download it, save the link, whatever the case may be. We encourage you to use this material to help your students in training when you start to introduce this. So lesson 3, lesson 4 are on the system now for you to work your way through. Some of you have requested schedules, so I've added in the schedule. Generally about a lesson a week is what we're shooting for. And we'll be hitting a couple more things, and then we'll be all wrapped up with this. But that's my part of the initial statement this morning. This stuff's out there, ready to go. And so right now I will open the floor after I stop sharing my screen and answer questions. So what do you want to throw at me? What questions you have? Let's talk about it.
I have one question about the 3D printer.
Yep.
I received mine, but I also received PLA and also resin.
Yep. You haven't got your second printer yet.
Okay.
Yeah. So which one did you get? The Sidewinder or the Genius?
I got the Genius.
Yep. So start with that one anyway. That would be your starting point. So your filament, Genius, those are together. The resin goes with the Mars when it gets there. And you're going to have a fun weekend with it. Dial that sucker in, get it printing. Other questions?
Eric, just a little logistic question from Vol State perspective. The shipment for the printers went to Gallatin, so Pat has the printers. I'm in Cookeville. I've got the monoprice printer that I got from the Nashville And I've also got a XYZ printing resin printer.
Mhm.
So I'm assuming I've
It
got
is.
essentially what you sent out, I think. So that's what I'm going to be, doing any of my activities on. Will be
That's fine. The FDM's the FDM. I do love the Genius because you will find its capabilities are really impressive for the price tag, especially that heat bed, which really improves your first layer adhesion. And that thing is just, it heats up like that and it maintains extremely well. So when you get a chance, run with it sometimes. But as far as FDM goes, what you have will work.
Okay. And then the XYZ printing resin printer, SLA printer, it works fine. It's done fairly well for me. It's the weird thing I've noticed about it is anytime I print a hole, the inside dimensions are off. The outside dimensions are usually right on, but the inside dimensions are a little, you got to play with them to get them right. I don't know if that's a slicer problem or just the printer itself or what. I don't know if you have any experience with that.
Well, we do have experience, but this is our process for most things, whether it's FDM or resin, is that we almost treat holes as pilot holes. And so we'll follow up especially if it needs to be really tight, we'll just basically design in the hole and then we'll run a drill through it at the end to get to the exact size that we're after. It's just kind of our standard process. A lot of times we don't even have to worry because it's close enough, but most companies are using additive. They're just going to use that quick post processing to finish it out.
Okay, that makes sense.
I will say this about the Mars. It's got the new mono screen on it, the new mono system, and it is faster. So you're going to see an improved speed in the Mars platform versus your XYZ from the older technology. So you'll be able to take advantage of that too. And the cost of these things are just dropping so fast, and yet they're getting so good and fast and much faster. It's really impressive. The other thing too is the open source nature of the resins that we're getting. I mean, we're getting some great engineering grade resins for like $30, and it's just crazy good. So really excited that you're all going to get the version 2 of the Mars and have access to it because it's so much faster.
Okay.
Yep. All right, others.
Yeah, thank you for these printers. I already set up both of them, but used the Genius. It's really fast and quiet.
Oh,
And,
it is.
The heat bed works really quickly. And I just printed the cube that came with it as a test cube. And it came very good. So Thank you again. Thank you very much.
Very welcome. You're all going to love these printers. And also, since some of you have already sent pictures of what you created, please keep doing that. We love to share out the stuff that's being made as a result of this project. So as you create more cool things, take a picture, shoot it to us. We'll put it out on the social media and share this kind of work. So, because we love seeing it, and it gets people excited that you can use it also for your own promotion. But yeah, you're going to love those. The AC heat beds on the Geniuses. You're really going to love that first layer adhesion capability. It really is good. Crank that sucker up. We'll talk more about that in the slicing lessons that I'll release out later on. But dialing that first layer in is going to you're going to help get rid of all those curling issues that you've been dealing with for years. It's going to be awesome.
Well, I do have a printer at home, and it has heated bed, but after a while, the adhesion becomes really bad. So I had to use painter's tape.
Yep.
To cover it to allow the adhesion. And sometimes I have to use the brim or the raft just to make sure the part sticks. Well, will this do the same thing? The bed will after a while?
Not really. What we have seen, because we've been running these type of beds for about 1.5 years now, and the one thing that will throw it off is over time the springs can move just a little bit, and so maybe re-leveling will improve your adhesion performance. But we will periodically, maybe once every 2 months, we'll take a little isopropylene alcohol, clean the bed off, and then reprint. Adhesion, what we have seen, is really controlled by how tight your first layer is and how hot that bed runs. So we generally, and again, I'll talk about this in the slicing lesson later on, we generally run a very tight first layer, like reduce it down to like 100 microns, and we generally run the bed at 80 Celsius. And so it's hot, it's good, strong. And what's really cool about it is that when it gets done, you just let it cool off. You don't pull it off. You just go ahead and let it room temperature on its own. You'll hear that thing pop itself loose.
Yeah, and when it contracts, yes, when the glass contracts, yes.
So I mean, just we did so many of those face shields with these things, and it just worked, just day in and day out. So I love them. I mean, they're getting better, but I love them as they are now too. Yeah. Other questions that you all have they can answer? How many of you all have experience with mesh mixer by chance? Just like show of hands.
Yeah, I have used it to just cut an STL file, for example, if I don't like a part of it, and sometimes it's just to fill gaps in the STL file, but it's not really that good for me, at least, because if you have a complicated design, you cannot reach anywhere other than the outside. You cannot cut other than in a plane, for example.
That's true. That is very true.
So, but I remember there was a software you add to Inventor with which you can edit the STL files, but you are limited to, I think, 5,000 segments or something like that. Yeah. And most of the time, it's even if it is a small and high resolution, it will take all the resources of the computer.
Yeah, you're
just
right.
To do it. Yeah.
Here's from a teacher standpoint and a student standpoint that you all can implement this. When your students create things and they break, for example, something just snaps and they're used to it. What we're also encouraging them to do is take their STL that they've modeled, put it into Mesh Mixer, and use the sculpting tools to add material where that break occurred. Almost like you're creating, it's almost like a bone break, and you are creating more bone right there, almost as if it's healing. So give them that, because it helps them understand that a break occurs where the material wasn't capable of handling the stress. And so by adding more material, but just where the break is, that gets things that way. And you
so why don't you do that in the design stage first to avoid Mesh Mixer?
Some students haven't done the understanding of it that way. So we don't get into like stress analysis into our second class. We let them print and fail. We actually want them to print and fail a lot. Oh, okay. Yeah. So, and to understand, all right, let's develop the intuitive understanding of how I can solve the problem and get away from just making it bigger, the whole thing bigger, when I'm only having this one little zone.
All right.
Anybody else got questions? All right, so with that in mind, we will be just adding in lesson 3, lesson 4 to the process. We will kind of be looking at maybe adding a little bit more into the hardware training too, as you all get to it, just to give you a few more tips. And then we will be, lesson 5 will involve the slicing, how we have seen the slicing settings to be most beneficial. Cura will be the software, the slicer of choice, simply because it's free and any student can have it. And it's got quite a few features, but we won't touch on them all because this is technically like the intro level kind of component. And then we'll throw in a little bit more advanced design with the fusion, getting into the shaping and dealing with more complex shapes. And then we'll have this off to the races. We will also have a few more of those videos, TED Talk like informational things or articles to kind of go on to build from there. And question on that one. So just from your all's thoughts, in lesson 2, we had all of these different concepts, 3D printing on the biomedical side, being a disruptive technology. Give me some thoughts from you all. What really spoke to you? What application was the thing that really got your attention?
Can you hear me?
I haven't actually listened to them. I looked at the list and kind of opened each. I was kind of looking for, of course, I'm an electrical engineer, so conductive stuff. So I didn't see anything there. But that's kind of my interest. And then certainly medical. Right now, I actually need a foot brace. So I'm thinking I need to, 3D print a foot brace for myself.
Yeah.
Because it just needs to hold my foot up. So it kind of got me interested in that. But Tim and I do the mechatronics, and it's just exploded in that area, and I've watched it explode. So, I think it's all great. I'm going to watch every one of those videos. So, and then
well, and there's one that's not on there, but I wish it just came out. MIT just released a prototype. They basically took a laser cutter, swapped out the head with this 3D printed multi-head system, and quite literally, this thing builds a robot all in one shot. So it cuts the plexi out, prints parts on top of that, lays down the circuitry, solders the circuitry, and then starts dropping in microcontrollers on top of that, puts it all together, puts a battery to it. That drone literally flies off once they open the lid. And it is phenomenal, simply because they can do it. I mean, it's worth showing your students when you get a chance. You can just actually Google MIT 3D printed robot. You'll find it. It's awesome. Anybody else have a category that they saw that they found interesting?
Well, I think I found 3D printing interesting in mostly prototyping. And if you need just a part or two, or either for your own use, because 3D printers are inexpensive now. So lately, for example, I have telescopes and I have observatory at home. So with the telescope, you need to take too many kinds of pictures. Some of these pictures is called dark pictures. These dark pictures, when you take them, the picture should be theoretically dark, and anything else is noise. So the software will remove it from your main picture in the future if you give it the dark picture. But to take the dark picture, you have to remove the camera, put a cover on it, and start taking pictures. But what I did is I designed something that I can insert in front of the camera while it is still installed on the telescope. And I put that on Thingiverse too. And I put it in a group for telescopes. And so many people printed it because first, it's inexpensive. It doesn't cost much. And second, it saves you lots of time. So that was one of the uses of the 3D printer. It's a tool. It's a tool at home. You don't need to run it all the time because you are not a factory, but you might need it. And then it comes handy, like in this case.
Yeah, absolutely. We actually had flooding last Sunday, and we had road shut down and everything, and I had a sump pump in my basement, and it has a backup sump pump that actually has kind of gotten old and broken off, and so I needed a cap really fast because it was basically the main sump pump was just cycling itself back into the pump. And that printer came in real handy because I was able to make that cap instead of me trying to stick a sock underneath this thing and hold it tight. to run
Yes.
the sump pump. So
Yeah.
it came in real handy, real fast.
Yeah, that's one of the really very good uses of 3D printers.
Yeah, indeed. Anybody else got any other thoughts that you want to have on this one, on this topic of just the big picture here?
Can you hear me, Eric?
Yes, sir.
This is, I'm lost as last year's Easter egg.
Okay.
My background is I've been a journeyman mold maker, tool and die machinist.
Mhm.
This is all Greek to me. So I'm trying to keep up.
Okay.
I'm just way behind.
All right. Well, that's no problem. And is there anything specifically I can do for you, like while we're talking now, that might be beneficial to push together?
I'm not, I'm not sure. I'm trying to get through some of the stuff, to actually draw the pieces out.
Yep.
In a 3D model and stuff.
Yep.
It's a big struggle for me because I've been in a world for 36 years that I made the stuff after it was already drawn up.
Right. You're working in reverse, right?
Yeah, I'm on the other side of it. So
yeah.
this is all new to me, and it's been a struggle, and just, with that side of it, it's been a real struggle for me. And like I said, we got, I teach a machine shop class. So we've got a 3D printer in here. They've only got 30 hours of it in our program and over 1,700 hours. So it's just a brief knowledge of it. So there's nothing wrong with them. I think they're awesome. I think it's awesome technology. It's awesome what they do with them. There's nothing wrong with it. It's just, I feel like I'm in the wrong place.
I understand.
Does that make sense?
It does. It totally does. The one thing I'll at least say this is the good news is this is not a rush thing. I mean, the material is always going to be there. And, we have, even when we put on the schedule, it's like, this is recommended. So the grant is not going to be like, you didn't get it done in time. We're going to pull this back. It's not going to happen. So it is a resource for you to grow at your own pace too. So we set times and those kind of things just for guidance. Yeah. But, if you're just chugging on and if you find a little useful feature here and a little feature here, I will tell you one thing that may be of interest to you, especially since we are talking about mold making, because the cost of actually all your students getting to make a no mold is just crazy high. Right. There is a process. It's not built into this material, but there is, moving forward, there is a way to actually print molds. And for short runs. Mm-hmm. So what we'll actually do, and we can do it both on the normal 3D printer and the resin 3D printer, is that to reduce that overall cost, we train our mold guys to basically design the mold, print the mold, and then they can do certain tests and greatly increase their opportunity to have experience with their own mold. But don't rush. Don't let it overwhelm you. Just progress as you feel comfortable and that kind of thing. And then just think, hey, I might be able to use this eventually. In fact, you can even, once you get those students, and if you have a student or two that has a little experience, let them start playing with it. Yeah. Let them start being your advocate and helping, to take some of that load off you too. But I think you'd be a perfect example for a new way of thinking, so that you can say, hey, we can start printing some molds and save ourselves a ton of money for some short runs, that kind of a way. So, but yeah, no pressure, no rush. We're not going to pull it back or anything. Just take your time.
Sure. Yeah, it's always been there. The technology's been there for a long time. And the side of it that I'm used to seeing is, okay, they used it for a prototype, and now they're going to find a way to, here's your print. How do we make this and mass produce it? I've been on that side of it. I hadn't been on this side of it as much. So we'll get there. Yeah. We're just, I'm a slow learner at this point.
Yeah, no problem at all. And knowing that too helps me a little bit, because now, later on, I'll probably shoot you some other stuff that we've seen on the mold side specifically that you might find useful. Because it's just new tech. And the 3D printing technology is not necessarily that new, but man, the materials we can print in, I mean, being able to literally print a mold that will survive, maybe 100, maybe 200 runs on a printer overnight. I mean, that's just crazy, right? You know, that's just something that was just phenomenal. So it can be a new type of teaching tool over time. But Rome wasn't built in a day either. So
That's right.
that's right. Cool. Anybody else?
Hey, Eric,
Can I just add what you're saying there, Eric? In terms of students, I steal students all the time for this stuff.
Mm.
Know a lot more than I do already. I'm not a big CAD guy, so I'm kind of finally getting myself into it. I do a lot of other software, I've been blowing it off. But I have a student that's already setting up my printers for me. They're super excited. Oh, you got printers. So she's in there, and I learn from my students just as much as they learn from me. And I tell them, I'm going to steal your information. I'm going to learn from that stuff, and constantly am. So I would recommend that, Monty, is just find someone that knows that stuff.
Yeah.
And just steal their files and print it.
Absolutely. Assign them to say, hey, can you model this up for me real quick? We need this. Here's this quick sketch to get that done. That is, I mean, it's great for everybody. It really, really is. So yeah. And that was going back to the other point. We love our students to fail. I mean, we want them running these printers as much as they possibly can. And that's why on the hardware side, as long as you show them how to keep it dialed in just right on that leveling, or a clog, or you're going to get clogs, and we'll have some tutorials added in to how to deal with those clogs as well. But you want them running these things 24/7. If they've got the excitement, let them go with it. They will make your life so much easier in the process, and it'll build. I think somebody had some other comments too. Did I hear?
Eric, just to follow up on your and Monty's talking about printing molds. You talking about injection molds? What type of molds are you printing and working on? Because that's a
there's materials you can print in that can handle injection molding for short run. So we do it a couple of different ways. One, we've got one of those little small handheld injection molders. And so we'll print a mold for, just some kind of part, some kind of trinket to start off with. We'll do one in FDM, like a higher temp FDM, and then do a lower temp, basically resin for the injection. And then it'll survive 2 or 3, runs there. When we're ready to go to a little bit larger number of runs, maybe a 100-shot run, we'll print with one of the resin printers that actually has resins that are designed for higher temp applications. And so you just print the mold, slap it in there, start injecting. That's really cool. It really reduces your costs when it comes to mold making, for sure. Otherwise, you're buying a lot of steel, a lot of aluminum, and that just adds up. And these molds can technically print overnight, so it's pretty wild. But yeah, just a whole. I mean, and I guess that's one way to really look at all this. Again, it's not so much about the printer; it's about the mentality. And the printers are just a means to an end to be able to utilize all these awesome new materials, all this awesome new design software. We won't get into the part of it, this particular class per se, but the generative stuff. I mean, it's just getting unreal good. And the printer is just a means to an end to apply this and to get you all fast prototypes, fast tools, fast this and fast that. And you can just walk away. One thing I'm really excited about is we got that automated system dialed in this week. If you want to check it out, you can watch it live stream on our YouTube channel. But this little system, I mean, it's taking a $200 printer and turning it into a fully automated system. And it just sits there and prints parts, clears itself, prints more parts, clears itself. You can add in different parts. We can remote in and tell it to print this or this and order. Print 20 or print 5, and it just prints and clears. And it's just fascinating. And then one of the things we're about to do with it is we're going to upgrade it so it can become a metal printer and actually print in stainless steel. And so now we're going to be fully automating stainless steel parts with nobody there and just running 24/7. So it's a means to an end to a whole new way of thinking.
So where will everybody go if you want to automate everything?
Also true. That is also true. Like any good disruptive technology, we get to take advantage of it. And our thinking is that it just introduces the opportunity to do something to focus more on like constantly improving to now I can make this better and this better and this better and this better. And it allows small businesses to start up a lot easier to get into this market.
Without people.
Yeah.
Without people, yeah, right?
Yeah.
Yeah, that's just for the money.
Yeah, that's
it's insane that we don't want people to work anymore. I heard in Sweden they started paying. It was just I think a test or something like that. They started paying people sitting at home $3,000 a month because they took their jobs. They gave it to the robots.
I got you.
Yeah, it's very difficult to compete in these markets these days unless you are high tech.
Yeah.
So where will the others go?
Yeah. It's an excellent question too. What we are talking to folks about is this. Let's look back 5 or 6 years ago. Automation was growing, mechatronics were growing, and now they are, you all know what's happening actually in the mechatronics field. I mean, we have companies in our area that all they do is make robots and conveyors for one reason and one reason only, is because automation is king. And it's going that way. Whether it's 3D printing automation or it's automation on conventional side, we want robots to do our work. That is just the in game here. So our logic is this: let's train people how to use those robots for themselves on a personal level as quickly as we possibly can, so that they can at least be part of that growth versus just replaced. So it's not even 3D printing that's causing it. It's just the fact that microprocessors are cheap, fabrication is getting cheaper, and automation's where everyone wants to be. And it's going to happen.
Have you heard about the Arduino?
The Arduino, like the pods?
The microcontroller, the small.
Yeah.
That's a whole computer in a very tiny.
It is.
Yeah,
Yes.
It's very tiny, and you can do lots of things with it.
Yes, that's actually what runs the automated printer I was talking about. That's
correct
right now.
A larger size. Yeah, it is.
Connects to the internet and everything. I can remote into it anywhere. It's crazy. But I digress. Sorry. Other thoughts or questions like on our material today that y'all want to ask about or get tutorials on?
So we received 2 printers. One is the normal one that I have been using for a while, but I have never used the resin one. What do we use the resin one for? Is it just the accuracy?
The resin will give you access to higher precision. The parts themselves will be a higher precision application. They can also be much easier oriented away from Z-axis weakness. So if it's a lot easier to put them on a 45-degree angle and build them, because they print in reverse. Beyond the design mentality, it's about the same, but it is just access to new type of material, higher precision. They in some ways can be faster than FDM, and they allow you to use resins that are not thermal resins. So for example, in the injection molding applications, you can use basically a photosensitive resin to make something that is very heat resistant to turn around and make a mold with.
Oh, okay.
So you're getting that, you have the 2 access fields of materials now that you get to play with, just because you have one type of printer and then the other type of printer.
Great.
Anything else?
Yeah.
Hey, Eric, I do have a question.
Sorry, go ahead.
Eric, like we haven't got our printer yet, but the resin one, how often do you have to change the tanks? The building platform.
So the one you're getting is not, well, let me make sure I understand it correctly. So the resin printer you're getting doesn't actually have one of those. It's not like the forms that has like the tank you have to use. You just fill up the tank. So, you just keep it filled as it goes or as you run out, and you're fine. So if you're using like the Form Labs, you'd have these tanks that are separate and you have to keep buying those. These are pretty simple. Now, as far as little bits of maintenance, your primary maintenance will probably be the screen itself, which we have tutorials on that too. But you shouldn't really have to do much with the tank at all for a long period of time.
Okay, thank you.
Welcome.
Let me
Just
ask,
keep it full. That's all you gotta do. Just keep it full.
let me ask a question about the stainless steel conversion that you're, so, you know, after you print that, what I've read so far, you got to print it oversized, you got to scale it up, and then you have to usually send it off to be centered or whatever process. What type of investment would it be if you wanted to scale up and do your own post-processing on stainless steel?
Excellent question. So there's a varied answer to it. That is true, have made molds. The one brand has it all built in. So you buy your roll of filament, it comes with tickets for post-processing. You print, we have a rough idea on the scaling. It's about 13% depending on certain directions. You ship it, they chemically debind, they sinter, they send it back. Process takes about 2 weeks. That you can pay them more if you want it faster. So if you're actually in production, you could do it that way. There's another brand that is focused on the localized ability. So you use their material and they actually have a small furnace that you can purchase, and what they consider their process for debinding and sintering. There is another company that is selling the whole package. They are selling a printer, the filament material, and a sintering system, and theirs doesn't require chemical debinding. In fact, theirs is actually water solvent. So what's really awesome about theirs is that you can print 2 parts, take a little wet rag, rub the top of the 2 parts together, slap them together, put them in the furnace, and they fully sinter with no seam. That package, couple $100,000, I think, is what they're doing. What I anticipate happening, though, is the fact that they've introduced that type of material. Somebody else is going to roll out the material itself and say, okay, buy this material, run it on your $600 printer, and then we'll send to this other place. So if you want to go so I guess what I'm saying is it's going to be changing a lot. But if you want to go to if you want to do this with the stuff that is like, ticketed process, you're looking at probably $500,000 investment. If you're looking at it with the number 2 group, that's basically saying, all right, here's our filament, here's our furnace. We don't have it fully dialed in, but you're going to spend maybe 10 grand, and you could probably do it in-house, which is actually what we are working on now, is getting that dialed in. The third option is probably going to be somewhere around 80 grand to set up and do it yourself. What I anticipate happening, or I'm hoping for, is as we set up these networks, like what we talked about previously, the RAMI initiative, as we set up all these networks of printers being out all over the place, we're going to eventually set up the ability to do sintering sites. So maybe one school out of the group has the sintering process and can speed it up for everyone else. Or they're going to get it dialed in where you can buy, an $8,000 little furnace and have it totally sintered in-house. So the price range is vast, but I'd say over the next 2 years, we're going to see a much more dialed in low cost accessibility. Because at the end of the day, it's all about the material, and the materials are just getting better and better. People are figuring out those magic recipes. So
okay.
Lowest price is probably going to be around 10 right now.
Thanks. Sounds
Yep.
good.
And titanium's coming. Inconel's coming. In fact, the company that has the stuff that's not fully dialed in just yet, they've got Inconel filament that you can print with. And it's just going to be a little bit more research and tweaking, and we're going to have it. Anyone else? Okay, well, so to kind of wrap it up for the morning, you've got lesson 3s out there for your viewing pleasure. Lesson 4, I'm just about done. The tasks are in there. And you also have your hardware tutorials. We'll add a few more. If you run into hardware issues, we love to know that. If you're having a problem, send us an email and say, hey, this is what's going on. If you can send me a video of what's going on, that's great. Or a screen capture or anything like that that I can work with. We will make a solution for it if we haven't already got one. And then we will send it back out for everybody. Generally on the filament side, you know, you're going to be dealing with clogs, and we've got tutorials on how to deal with that. Leveling is usually your leveling and your temperatures and your speed of your first layer are generally what takes care of your adhesion problems. But we like to know what's wrong and send it to us so we can make our process better. Otherwise, anybody got any other comments? George, you have any follow-ups on the evaluation side or anything of that nature?
Not right now.
Okay. All right. Ismail, do you have anything that you want to throw in? Or Michelle, Elaine, anybody? Okay, so that means we're wrapped up then, and thank you all for your time this morning. I do hope you have a great weekend, and don't forget to send us those pictures as you start printing things. It's going to be the best part to share and show off the stuff that you all make.
So let me just say that I shall be doing an evaluation next in the next session. So at the end of the next session, we'll have a comprehensive evaluation that covers everything that you have that we have done so far over the last few weeks. So I will kindly ask all of you to help me with that. Okay. About 10-15 minutes. Thank you.
And George loves pictures too. So, you know, as you all make that stuff, it's great for him to include his evaluation to show off the cool things that you print with this. Or even, as screen captures. That's another thing that we can prove too, is the fact that as you all, or even the students that you're working with, if they start using Fusion and Mesh Mixer to create some more interesting things or prototypes, tell them to take a screen capture, send it to you, send it to me and George. And we can add that into our evaluation too. Those screen captures of what designs are out there, that's useful information.
Absolutely. Even when you bought something, you know, and it's bad, just take a picture of that, and that can be a learning tool.
Yes, it is. All right. Well, everybody have a great weekend. If there's nothing else. Okay.
Thanks,
Yep.
Ismail.
Yep.
Thank
Thanks,
you.
Eric. Have a great weekend.
Thank you, sir.
Thank you all.
Thank you. Bye-bye.
Thank you.
We'll see you.